Okay, so we're going to be doing our warm-up here. The first thing says write an equation for the nth term. Well, for all of these problems, you need to have your formulas pretty much memorized, right? You can't get away without that. So the nth term is the first term plus the difference times n minus 1. Then we had two formulas for sum. The sum of n terms is either n over 2 times the first term plus the last term. Or if they don't give you the last term, but you do have the common difference, you can say n over 2 times 2 of the first terms plus d times n minus 1, which is basically just combining this and this. So in place of the a sub n, they're putting that full formula. Okay? So those are the formulas you have to use. So if I'm looking at this problem here, what is my common difference? We're constantly adding 4. What is my first term? We've said the common difference is 4. So we're looking for the formula, which is actually very straightforward, very simple, hopefully. So we're going to say the nth term, nope, sorry, wrong letter, is the first term plus the difference times n minus 1. And when we work this out, 4 times n is 4n, and it will be minus 4. And combining like terms, we'll say the nth term is going to be 4n minus 1. I don't care if you put negative 1 plus 4n, it's the same thing. So that is your first part of this, writing the equation. The second part of this is actually finding the 120th term. So a sub 120, and you're simply putting in that 120. What do you get for your 120th term? 479? Is that what I heard? Okay. 479. Hopefully not too terrible of an expectation. Are we doing okay so far? For the next one, we're trying to solve this time around for n, so I'm plugging this into the equation I have. The last term is the first term plus the difference, in this case that's minus 4, times n minus 1. Okay, this is not crazy difficult, but the number of folks who are making mistakes on this is outstanding. What do? You can distribute. I actually prefer to, I think it's shorter if you just do order of operations backwards, so I subtract 6. And then if I divide by negative 4, how many times does negative 4 go into negative 76? You can use a calculator if you need to.
19 times.
19 times. So what is n? 20. You can distribute and work it out. That's just, I think it's 1 or 2 steps more. But it should give you the same answer either way. Now, what's the problem on number 3? Why is this a difficult thing to do? Yeah, you don't know how many terms there are. I know that the first term is 100. I know that the last term is 32. What else do you know? D is negative 2. So before we can actually find the sum, we need to figure out what n is. So I'm going to put that into my formula. So the last term is the first term plus the difference, or in this case minus 2, times n minus 1. Now yay for calculators. You can use your calculator. What is 32 minus 100? Negative 68 is negative 2 times n minus 1. So n minus 1 equals 34. So what is n? 35. Beautiful. So n is 35. We have all of this other stuff. To me, the easiest equation to use for sum is this one. It has the fewest things that need to be plugged in. So that's what I'm going to do. I'm going to say the sum of the first 35 terms is 35 over 2 times the first term plus the last term. And when you plug that into your calculator, what do you get? 2, 3, 10. 2,310. All right, so are we feeling pretty comfortable with this so far? It's really just being able to use your formulas. Now, for the last one, it's a word problem, which you can expect a lot of these guys. 392 is what?
Sum.
That's your sum. That's how many cans you have. That is your total sum. What is 2? That's your first term. And then a number that's written out in words, what is 3? Your common difference. And what are we looking for? How many rows? So what thing represents how many rows? N. N is what we're looking for. So we want an equation that ties sum, first term, difference, and n. So I'm going to use this formula right here. Sum, number of terms, first term, difference, and n. You can only have one variable in the equation to solve for. So I'm going to say the sum of n terms is n over 2, 2 times a1, plus the difference times n minus 1. So 392 is equal to n over 2, 2 times 2 plus 3 times n minus 1. What is 2 times 2?
4.
And 3 times n minus 1? 3n minus 3. So when I combine that, I will have 392 is n over 2 times 3n plus 1 or 1 plus 3n, it doesn't matter. Now at this point in time you have the choice. If both of these numbers were even, I would have divided them by 2. But they're not, so how can I make that go away? Multiply by 2, good. So that's going to drop away. And 392 times 2 is 784. And then I'm going to distribute the n. So it'll be n plus 3n squared. If I have an equation with both n and n squared in it, how do I solve it? Factor, but before that, get it equal to 0. So I'm just going to shift some things around. 3n squared plus n minus 784. Now I'm lazy. I am not going to factor that. I'm going to put it in my calculator. So what I do is I go to my y equals and I type that equation in. Okay? 3x squared plus x minus 784. All I need to do now is do the second graph to get to my table, and I'm looking for the point where I get a 0 out. So what is n? 16. And that's all you need to do for this. I am not going to expect some crazy amount of work to solve that final piece. All right, so how are we doing with that warm-up? Pretty good? Okay. So what we're going to do now is I'm going to show you guys the answers to your homework, give you a chance to check those. So take a look at what we've got here. I will scooch it up. Please understand that when we're looking at the equation for the nth term, I don't care if you do negative 6 plus 4n or 4n minus 6. It's all up to you. All right, so here are the last answers. All right, so are there any questions on these homework problems? Yes, Dylan?
32.
Okay. Would help if I had the textbook handy. And what the question was. Here we go. So your question was on number 32, correct? Yes. All righty. So 32 gives us the fifth term is negative 2, and the 13th term is 30. And we're looking for everything here. Okay? So that means I need to know what the number of terms are. I need to know what the difference is. I need everything. So using what I have, I always put, of these numbers here, I always put the higher term, not necessarily the bigger number, but whatever term that is over on the left-hand side. And I've got the fifth term, it's going to be plus the difference times this number minus this number. So 13 minus 5. So the 13th term was 30. The fifth term was negative 2. 13 minus 5 is, and then we just need to solve that equation. So 32 is 8D. What is the common difference? 4. So hey, that's one more piece I needed. Now the last piece I need is the number of terms. Okay, do I need the number of terms? No, it just says, first term, common difference, we don't need this guy. Okay, so I do need the first term though. So I don't care. Do you want to use the fifth term or the 13th term? The fifth? Okay. So using the fifth term, I'm going to say the fifth term is equal to the first term plus the difference times this number minus this number. So the fifth term was negative 2. 5 minus 4 is 1. 4 times 1 is, well, hey, that's nice. So the first term here is just going to be negative 6. And you plug all that together to write your equation. The nth term is the first term plus the difference times n minus 1, making sure we always simplify this stuff. So that's 4n minus 4. So the nth term is going to be negative 10 plus 4n, or 4n minus 10. Nice. Stay dry. Did you tell him thank you?
I did.
Okay. All right, one more question. Yes? 30. 30, 30, 30, 30, 30. 30 gives us very similar, same set of instructions. So the 8th term here is 4. The 18th term is negative 96. So I'm going to do it just the same way I did this guy. Just start chucking things into your equation and see what falls out. So I'm going to put my higher term first. So 18 is a to the 8th plus the difference times this number minus this number. So plugging those guys in, negative 96 is 4 plus, and that's going to be 10D. So if I subtract 4, you will have negative 100, and then divide by 10. What is your difference going to be? Negative 10. Okay, so I got to start chucking things back into the equation and see what falls out. Now I need the first term. So since this is your question, Akila, do you want to use a sub 8 or 18? It really doesn't matter, but I want to stick with whatever you used. So we're going to say a sub 8 is a sub 1 plus the difference times 8 minus 1. So my 8th term here was 4. First term we're looking for. 8 minus 1 is 7. And the difference was negative 10. So 7 times negative 10 is negative 70. So I'm going to add 70 to both terms, or both sides. So my first term is 74. Then I just put it all back together again. Assemble those pieces. My nth term is my first term plus the difference, or in this case minus 10, times n minus 1. And then we have to combine like terms, so that's going to be minus 10 n, then plus 10. So that's where 84 comes from, minus 10n. Okay?
I just read with that is 8 sub 18 equals -9. So I got all a bunch of weird fractions and stuff.
Yeah, you'll get weird stuff. Gotta be careful. Rule number 1, copy the problem down correctly. That's usually a good starting point. All right, so these general formulas and the ability to use them are really the focus of what we're doing here. Now we're just going to switch gears a tiny bit, and we're still talking about sequences and series, but now we're moving on to geometric sequences and series. So what I would like you guys to do, you need to get all of this stuff written down for me, please. Excuse me. I'm an awesome sneezer.
Will you get like an email?
You're talking about cancellations and stuff?
They announced it last time.
You're not going to have an early dismissal today. They would have had to announce it, they would have to have informed teachers prior to the start of 4th block or 5th block. Okay? Odds are we will find out that everything after school is canceled. They've already canceled the after school buses. We will, not the rides home, but the activity buses. You can still get home. It's okay. But we should be able to find out pretty soon what the dealio is. But yeah, we have not received any additional emails. Who is? Fuck here, but yes, they're also closer to the weather. They're higher elevation. So close, but so far away. Okay. So in our geometric sequences and series, we're switching things up. We still have a first term and a last term. But in an arithmetic sequence, we had that equation where it was a difference, that we were constantly adding or subtracting the same number over and over again. For geometric, we have a ratio instead of a difference. And you want to pay close attention to that, because if they use R versus D, that's going to mean completely different things. Okay, so when they have an R, you're talking about ratios, you're talking about geometric, and this is the formula you use. If you see a D, it's arithmetic, and you use the other formulas. Okay, but we still have the first term. Ratios occur because we're constantly multiplying by the same thing over and over again. You can find the ratio, for example, by taking the second term and putting it over the first term, or the third term over the second term, or any term over the term that came before it. That's how you can find your ratio. You can do it any of those ways. And it's still the number of terms. Yes, sir?
Can you post these sheets online?
I do.
In the class?
Yep.
No.
Yep.
Before class?
No. I post completed notes, because I don't always have it ready before class.
Like my homework?
Sure. Well, no, I sometimes have to tweak it based off of what we did the last class, what we need to go over. So.
I also like my homework.
Also like your homework? Okay. All right, so what I want you guys to do is just go ahead and write down the numbers they gave you for numbers 1 and 2. Now you want to be very, very careful with these. They're not always going to come out and tell you, hey, guess what? We're doing a geometric sequence. Or woohoo, it's arithmetic time. That was weird. They're not going to do that. You have to be able to recognize it for yourself. So are we adding or subtracting, or are we multiplying or dividing? Multiplying. And the way you can figure out what your ratio is, again, you can just take the second term over the first. You can do the third term over the second. It does not matter. What does that give you? 4. We have the first term. So now all I'm going to do is plug it into the equation. Now this is really, really crazy complicated stuff. Okay, so pay close attention here. So my nth term is my first term, which is 4, times my ratio, which is to the n minus 1 power. That's it. No, seriously, that's it. Okay, we've got a dapper in the back of the room. That was just weird. T-money. Yeah. Okay, are you okay with that? Now, the second stage of this is asking for the 13th term. So, I know this is crazy difficult. How do you find the 13th term? Plug it in, plug it in. What is 13 minus 1? Now, please remember your rules of exponents. This 12 only goes to this 4. But some kind of cool things happen here. These are just so happen to be the same base. So review with me a rule of exponents. What would this actually be? 4 to the 13th power. Simply because same base, add exponents. And then all you do, because yes, you definitely have calculators here. I'm not going to ask you to do 4 to the 13th power in your head. Okay? 4 to the 13th. And don't do what I do. I tend to skip letters or numbers. It is not 12 because we had that 4 out front. You could do, and if you watch, 4 times 4 to the 12th gives you the same number because 4 to the 13th is the same thing as 4 times 4 to the 12th. They have the same base. No. Well, just on this one, just because that 4 was out front.
So if it was any other number. Okay.
Yeah. Okay? And so for this, I get 6, 7, 1, 0, 8, 8, 6, 4. All right, so that is 67,108,864. Maya.
Why is it so large?
Because you're constantly timesing by 4.
Yeah.
So 4 times 4 is 16, times 4, times 4. You see how quickly that grows?
Yeah.
That's why it's big. This is called geometric growth or exponential, because you're constantly multiplying by something rather than adding the same constant term. Okay? And we'll see what those graphs look like in a second. All right, so, you know what? Why don't you guys do number 2?
Can we just leave it as a fraction?
Yes, your answer must be a fraction. The only time I will accept a decimal in your answer is if there was a decimal in the original problem. Do you understand what I'm talking about? Okay, I want to see fractions. Shush. Really quickly, what is your ratio here? 1/3. Yes, I know some people might think, well, we keep dividing by 3, but a ratio is what you multiply. So if you're talking about division, it's times a fraction. All right, so let's see if you were able to plug this all in and get the final answer correctly. Here you go. Now, I did more work here than I really would expect you to do. I expect everybody to get this. I showed you this next step because I needed you to understand 12 only goes to the numbers inside the parentheses. The 12 does not go to the 81. So, that's 1 to the 12th, which is just 1, over 3 to the 12th, which is 531441, and the 81 is on top. Because when you multiply fractions, it's numerator times numerator, denominator times denominator. And then you simplify. You could do all of that work separately in your calculator, or you can just type into your calculator 81, let me get that glare, 81 times 1/3 to the 12th. And if it gives you a decimal, math, enter to your fraction. Okay? All right, the third problem says, okay, this time we're given the 8th term, we're given the ratio, we want to find the first term. So go ahead and write that information down. Were there any questions on number 2? Sorry, I forgot to ask. No? Bless you. Stop it. You get 1, you don't get multiples. So we're still looking at geometric because of that R. And so I'm going to say A sub 1 times R to the n minus 1. Anybody want to take a guess at what we do? Plug in the numbers, yeah. The 8th term is 8,192. The first term we're looking for, the ratio is 4. What number is going to go up here? 7. Beautiful, because that's 8 minus 1. Does the first term get the 7th power?
No.
No. So again, you do not need to do 4 to the 7th in your head. You can just do it in your calculator. And then say 8,192 is the first term times 16,384. So now I'm just going to do my 8192 divided by that puppy. And if you can't tell that 0.5 is 1/2, math, enter to give you a fraction. Hey, you never know. Okay. So if you would please, try number 4. Beautiful thing here is if you understand the concepts of arithmetic, it's just a small hop, skip, and a jump to geometric.
Number 4, did you mean to put D? Was that?
Those of you who can't see me, eyebrows up and down. Wink, wink. Nudge, nudge. What do you think? Yes, I meant to put the D. Just because we're doing a lesson on geometric doesn't mean that's the only thing in the whole wide world. You have to be able to tell the difference between when we're doing arithmetic and when we're doing geometric. Why did I know that 3 was geometric? Because it had an R. 4 has a D, so that means arithmetic. So your answer for this one, unfreeze, there we go, is 25. Did anybody do it as if it was a ratio? Does it work out at all? Yeah, no. You could do that. You could use an ln, but we're only talking, and that's a really good point to make. Ladies and gentlemen, when you are solving this, n is always going to be a positive integer. If you do not get a positive integer back, that's your red light flashing going, no, fix it, there's something wrong. And they probably will not use that voice. Alrighty, so these are arithmetic sequences. How to find each term. What did we do after sequences for arithmetic? Series. So now we're going to do geometric series. Okay? So let's have y'all start by writing down your formula for the geometric series. How to find the sum when you are constantly multiplying by the same guy over and over and over again. Yes. So for our geometric series sum, the sum of the first n terms is found by taking the first term times 1 minus the ratio to the nth power over 1 minus the ratio. Do not be tempted to simplify 1 minus r to the n over 1 minus r. It won't work. And what I would like to recommend that you guys do is always put your ratio in parentheses. Absolutely always. Okay? All right, it's a very simple equation. This to me is actually easier than the arithmetic series because you really have 1, 2 variables. First term and ratio, boom, that's it. So to find the sum, what we're going to do is we're going to say the nth sum, so in this case n is 7. So the sum of the first 7 terms, what goes first? It's just a matter of putting things in the right place. What goes first? 8. Times 1 minus, and this is why you need parentheses. Negative 2. Do not just automatically say, oh, a negative and a negative is a positive. Yes, that's true, but because this 2 has a power to it, that could be a positive number or a negative number depending upon what the power is. Now this guy is very easy to do, which means it's also very easy to mess up. So if you're not always confident in your work, just go ahead and do it on your calculator and you can type it in exactly as you see it. So go to alpha y equals to get your fraction bar and then just type it in. Put the parentheses in though. 1 minus parenthesis negative 2 to the 7th over 1 minus negative 2. I cannot tell you how often I see sign mistakes with this. It occurs so often. So we get that the sum is simply 344. Now, one thing that you want to be aware of, because that 2 is negative, if I simply change the exponent, that might do a lot of difference on my actual answer. So all I'm going to do is I'm going to change that 7 to an 8 and show you what that does. The next term, if I include the next term, now not only is my sum negative, but it's hugely negative. Way different. If I change that 8, oops, to a 9, it bounces back to positive. Do you understand what I'm getting at here? So this is just going to keep bouncing back and forth between a positive number and a negative number. Okay? I want you guys to try for me problem number 6, please. Just do the best you can, okay? And please notice that in the sum formulas for this guy, it's not n minus 1, it is just n. Quickly, please. And unless they give you a decimal in the original problem, I want no decimals in your answers. You guys got it? What did you get? Woo! I'm hoping I got 105 over 32. I was like, oh, I'm hearing some weird stuff. 105 over 32. Yeah, that's all I did. You can even see here what I did. I just literally typed it straight in.
For some reason, I did to the 7th power.
Oh, that'll get you. Sure. Let me zoom in.
So, what I did is, instead of just using the fraction negative 1 over 2, I just did
Negative 0.5?
1 minus negative 0.5, so 6 power.
But did you put it in parentheses?
I did not.
That's why. If you do not put it in parentheses, it'll give you a completely different answer. Let me show you. Okay. Completely different answer.
That's not my computer.
Right?
Wow.
I don't know then, but you do have to make sure that that negative gets the exponent. If you do not put the parenthesis around the negative number, it's just going to give the actual number the exponent, and it's going to ignore the sign completely. So you need to be very careful. Always put the parenthesis around it. You can use 0.5, but put negative 0.5 in your parentheses. Cameron, do you have a question or just making your hair look sweet? Okay. All right, I want to show you something. And I'm actually going to use these two equations kind of as my go-to. So my sum formula, so I'm going to look at number 5, says take the first term, let me do it this way. First term times parentheses 1 minus negative 2 to the nth power, so I'm just going to put an x in that position, over 1 minus negative 2. So that's my first equation. For the second one, I'm going to do this guy. So alpha y equals again, the first term times 1 minus the ratio to the nth power divided by 1 minus the ratio. Okay, so you guys understand what I just did? Nothing crazy. I put the first, number 5, I put that in my first equation. I put number 6 in my second equation. All I want to do is I want to look to see what happens as I constantly go to larger and larger numbers of terms. Okay? So I'm going to go to my table. And I'm not looking at the graph because we're only using integer values here. So if I go to my table, we can see first term, second term, on and on and on and on and on. As my first equation, as my x gets bigger and bigger and bigger, am I going to any specific number? Am I getting closer to anything in particular? Because I can keep going here, and it's just going to keep bouncing back from a positive to a negative, and these numbers just keep getting huge. So it's not going to be approaching a specific term. Now, if I look at the second equation, which now I'm believing I put the wrong thing in, did I leave off the negative? No, I did not. Okay. So if I look at the second equation, is this one getting to a specific number? Yeah, it's starting to get towards what?
Through there. 3.3 repeating.
You see how that's getting to 3.3 repeating? Over and over and over again? That's because these represent two different types of geometric series. And that's what I've got next. These are called infinite geometric series. And what that means is if I were to keep going on and on and on and on and on, if I were to take that a sub 1 times 1 minus r to the nth power over 1 minus r, and I were to let that n, go to infinity, what would happen? Well, notice that we're saying 1 minus whatever that is. Okay? If your ratio is less than 1, or the absolute value, we don't really care about the sign here. If the ratio is less than 1, then a fraction to a power is just going to get smaller and smaller and smaller until it basically disappears. So that pretty much gets to go away, and that's where this formula comes from. Now, if r is a number bigger than 1, or an absolute value bigger than 1, this guy just gets infinitely huger. Bigger, 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 bigger. So, if your absolute value of your ratio, in other words, we're just disregarding the sign, if that number is bigger than 1, your sum, it is a divergent series, so we would say the sum does not exist. Now, if your ratio absolute value is less than 1, then we can actually calculate what that infinite sum is and say it's going to converge to a sub 1, your first term, over 1 minus the ratio. Annabelle, you need to take out paper and write this down. Then you need to get some from somebody.
Quick thing. If I realized something later, and my teacher's constant email that says I'm going to go to the last lunch. Just
Why?
because we didn't have a chance to. It was hailing on us. And
Oh, so were you at the, was this the field trip?
Yeah, and we
Okay.
came back early, so I just back.
And a piece of paper. Start writing stuff down.
Okay, we can do that.
All right. Yes.
Let me show you what I put in the calculator.
Yep. Bring it up here. Hurry up.
I put the parentheses.
Because you
back.
put the 5 inside the parenthesis.
No, wait, no, yeah, that was outside the parentheses.
Well, it's inside right now.
Prior to that, it was outside.
Watch, I'm gonna take it outside, put it in season.
Now the problem is you're using a minus sign instead of a negative. So if that was a negative, here it goes.
What?
Okay.
This is witchcraft.
All right, so what we want to do for these problems is we need to start by figuring out, number one, is it geometric? Because if all I'm doing is adding 3, it's just going to keep getting bigger and bigger and bigger. It's going to go to either a positive infinity or negative infinity. So we don't have infinite arithmetic series. But if we are talking about geometric, start by finding the ratio. So go ahead and write 7 and 8 down. And while you're at it, see if you can find what the ratios are. All right. So, on number 7, what is the ratio? 1/4. What about number 8? What was the ratio on number 8? 2. So let's start by figuring out whether or not there is an infinite sum. Okay, does it converge or diverge? What about number 7? Does it converge or diverge? It converges because the absolute value of that is less than 1. It's like, have you ever heard the trains or all the people converged on the mall to protest? Or all of the voters converged on the voting location to vote? To converge means to draw together to some central location. So this converges because we continuously add a smaller and a smaller and a smaller number, so it almost doesn't even matter. For a convergent sum, you're going to take your first term, which is 8, put it over 1 minus the ratio. What's the ratio? Now, if you're having trouble with your calculator, you can do a lot of this step by step by hand. What is, as a fraction, 1 minus 1/4? 3/4. But I don't like to divide by fractions. So what was that, Matt?
Oh, flip it.
Flip it. Multiply by the reciprocal. So this is the same thing as saying 8 times 4/3 or 32/3. Or, if you are okay with using your calculator, just add it in. 8 divided by 1 minus 1/4. Math, enter. Do not give me a decimal unless there is a decimal in the original problem. Or if you have absolutely no choice because it's using crazy radicals and all that jazz. On number 8, the ratio was 2. What kind of a series is that? Divergent, starring Jennifer Lawrence. No, wait, wrong movie. Shailene Woodley, there you go. That number is bigger than 1, so that is a divergent series. And if I asked for the infinite sum, that guy doesn't exist. There's nothing you can do about that. Yes, they've got it on very loud next door. Huh? Yes, but if you were to buy the series, you would buy all of them together at once. See? Boom! All right, how are we doing with this stuff? You're like, I'm waiting for the shoe to drop. I'm waiting for it to get harder. All right, so here's how hard I can make it. Word problems! See what you can do. It's actually not that much money. If it was $43,000 you started as your payment, yes, in Northern Virginia, that is not a lot.
That's how much songwriters make, like starting songwriters.
Yeah. No, I think my starting salary was in Georgia, and my starting salary was $26,000 a year. It was not all that long ago. I think right now they're at the starting salaries there to be like $33,000.
That's like college.
Yup. This is not a money-making scheme, that's for sure. right, so I want you guys to work through this. And I want you to kind of think of something for me, all right? If you're getting a 3% annual increase in your salary, that barely covers cost of living, by the way. If you're getting a 3% increase in your salary, should your next year's salary be bigger or smaller? Bigger. So think about that when you evaluate your answer to see if what you got makes sense. You can, but you got to know what kind of thing we're using. You can borrow it, but you can have it. I probably don't want it back. Yes, I'm one of those irritating people, if you haven't noticed. Bless you. Okay. So, how much should this teacher be making in the poor country or county of Prince William? It's not a country, yeah. In the poor county where we barely even get cost of living allowances. Or raises barely cover that. After 5 years, what will you be making? $48,000 $396.88. The reason why I brought up that idea of make sure it makes sense is because my rate here, my ratio, is 1.03. Because you were going to keep all of your previous salary, that's the one. And you're adding to that 3%. So if you had used just 0.03, you would have had a very tiny number. And I really hope you're not working in a job where you steadily lose money every year. That would stink. Please don't take that job. Okay? So at the end of 5 years, this is what you should have. And if you got that first part, if you understood that the rate was 1.03, the rest of it really does come pretty simply. Okay? So if you know anything about salaries, there are people out there who make this in 1 year. Yeah, not me, but there are people out there that make that in 1 year. So if money is important to you, don't be a teacher. There are other benefits. Money is not one of them. Okay? How are you doing with this? Doing decent? All right. I'm going to give you a worksheet. This worksheet is going to be both your classwork and your homework. Now, we still have a good 25 minutes. Okay? Oh, 15 minutes? No, 25 minutes. What did you talk about? We have 25 minutes. You should be able to finish those 5 problems. When you are done with those 5 problems, bring them up to me. I will check them for accuracy, and then you can start working on the homework. Yes, ma'am. Then you know what you're going to have to do, and when you come back, those are the problems I'm grading for accuracy. Okay? Yep, worksheet's coming right now.
And they like, there's brown to the center. You can't It's like Ziploc bag, it's like grocery bag, you cannot recycle.
All right, ladies and gentlemen, let's focus, please. Guys, so you have your classwork. You are welcome to work on this independently or together, I don't care. But I need to see those 5 problems done before you leave here today. Now listen up really quick. The only problems that I will accept a decimal on are problems where the initial question started with the decimal in it, or specifically problem number 22. 22 is the only other problem that I will allow you to do a decimal in. Okay? Get started.